Hello guys, welcome back to Artificial and Facts channel. In this video, we will talk about the bell curve, or also known as a normal distribution curve. So please enjoy the video. Data can be distributed or spread out in different ways. It can be spread out more on the left, more on the right, or it can be all jumbled up. But there are many cases where the data tends to be around a central value with no bias left or right, and it gets close to a normal distribution like this, here in the slide. The blue curve is a normal distribution, and the yellow histogram shows some data that follows it closely but not perfectly, which is usual. It is also often called bell curve because, as you guys can see, the curve, it looks like a bell. The normal distribution has a mean, median, and mode. It is also symmetry about the center, and it has 50% of values less than the mean and 50% greater than the mean. Now, to understand more about the bell curve, you need to know about two metrics. It is the mean, the average value of all the data points, and the standard deviation. It shows how much the dataset divides from the mean of the dataset. A bell curve is a symmetric curve centered around the mean, or average, or of all the data points being measured. The width of a bell curve is determined by the standard deviation. 68% of the data points are within one standard deviation of the mean. 95% of the data are within two standard deviations. And 99.7% of the data points are within three standard deviations of the mean. When you have a data set that is normally distributed, your bell curve will follow the below rules. The center of the bell curve is the mean of the data point, also the highest point in the bell curve. The 68.2% of the total data points lie in the range, which is mean minus standard deviation to mean plus standard deviation. And 95.5% of total data points lie in the range, which is mean minus 2 multiplied with standard deviation to mean plus 2 multiplied with standard deviation. And 99.7% of the total data points lie in the range, which is mean minus 3 multiplied with standard deviation to mean plus 3 multiplied with standard deviation. In the bell curve, the highest point is the one that has the highest probability of occurring, and the probability of occurrences goes down on either side of the curve. It is often used during employee performance appraisals or during evaluation in exams. Do you ever heard you will be graded on the curve? So now let's see how to create a bell curve in Excel. And this example is based on trumpexcel.com and mathisfun.com. And in this example, this is an example of a class of students that have been scored in an exam. You can also make this too in your company. The mean score of the class is 65 and the standard deviation is 10. You can calculate the mean using average function in Excel and standard deviation using the std.p function. Here are the steps to create a bell curve for this dataset. First, in cell A1, enter 35. This value can be calculated using mean minus 3 multiplied standard deviation. So it will be 65 minus 3 multiplied with 10. So it will be 35. And second, in the cell below it, enter 36 and create a series from 35 to 95, where 95 is mean plus 3 multiplied with standard deviation, which is 10. So in Excel, it will look like this. And then we next to the step 3. In the cell adjacent to 35, enter the formula equals normal distribution A1 65 10 and then false. And then again use this fill handle to quickly copy and paste the formula for all the cells, as you guys can see here in the Excel. And then next, to select the dataset and go to the Insert tab and insert the Scatter with Smooth Lines chart here in the Excel. So go to Insert and go to Scatter with Smooth Lines chart. And then the table of the bell curve in Excel will appear and look like this. And that's for how to creating a bell curve in Excel. Next is how is the bell curve used in finance. Analysts will often use bell curves and other statistical distributions when modeling different potential outcomes that are relevant for investing. Depending on the analysis being performed, this might consist of future stock prices, rates of future earning growth, potential default rates, or other important phenomena. Before using the bell curve in their analysis, investors should carefully consider whether the outcomes being studied are in fact normally distributed, because failing to do so could seriously undermine the accuracy of the resulting model. In finance, standard deviation that depicts the returns of a security are known as volatility. For example, stocks that display a bell curve usually are blue chip stocks, and ones that have lower volatility and more predictable behavioral patterns. Investors use the normal probability distribution of a stock's past returns to make assumptions regarding accepted future returns. Bell curves are also sometimes employed in performance management, placing employees who perform their job in average fashion in the more normal distribution of the graph. The high performers and the lowest performers are represented on either side with the dropping slope. It can be useful to larger companies when doing performance reviews or when making managerial decisions. And on to the conclusion. The term bell curve is used to describe a graphical depiction of a normal probability distribution, whose underlying standard deviations from the mean create the curve bell shape. A standard deviation is a measurement used to quantify the variability of data dispersion in a set of given values around the mean. The mean, in turn, refers to the average of all data points in the dataset or sequence and will be found at the highest point on the bell curve. Financial analysts and investors often use a normal probability distribution when analyzing the returns of a security or overall market sensitivity. Also, bell curve or normal distribution can be created and made with using Excel because it is an easy way to create a bell curve or normal distribution curve. So that's all guys for the bell curve, or also known as a normal distribution curve. Really hope that you guys can understand well the video and you can use it when you need it, and hope you guys can have a blessed day. So thank you so much for watching, and also thank you so much for listening to this video. And please don't forget to kindly like and comment and share this video, and also don't forget to subscribe to this channel, Artificial and Facts channel, so that you guys can see the other useful video. So that's all guys. See you guys next time. Bye.